Okay guys, welcome back to another video. Today we will take a look at Lucus sequence and prove this inequality. So consider this sequence 1, 3, 4, 7, 11, 18, 29, 47, and 36. As we can see, the first two terms of the sequence are given. And the next term is the sum of the two previous terms. 4 is obtained by 1 plus 3. The next term is 7, which is obtained by 3 plus 4. 11 is obtained by 4 plus 7. 18 is obtained by 7 plus 11, and so on. Okay, so the term that is so from the third term is going to be the sum of the two previous terms. So we're gonna have n equal to n minus 1 plus a n minus 2 for every positive integer n such that n is greater than or equal to 3. And we are going to prove this inequality. If an is a Lucas sequence, an is going to be less than 7 over 4 raised to the power of n for every positive integer n. Okay, for this example, I'm going to use strong induction. Okay, let's use strong induction, which is this one. Sorry, I'm going to use the second principle of mathematical induction. Okay, let's get started. Let's prove this. So we let an be the Lucas sequence. Okay, and let Pn be the given this inequality, an less than 7 over 4 raised to the power of n, and we will use a proof by strong induction. Okay, so we start with the base step. What's the base step? For base step, I want to plug in the value of n. Start from 1, and 2. Okay, so when n is 1, what do we have? We will have a1, and a1 is 1, which is less than 7 over 4, and 7 over 4 is 7 over 4 raised to 1. So it satisfies this equation, so P1 is true. Okay, P1 is true. Okay, when n is 2, what do we have? When n is 2, we're gonna have a sub 2 equal 3 right here, and 3 is equal to 48 over 16, right? But 48 over 16 is less than 49 over 16, and 49 over 16 is 7 over 4 square. So the second term is less than 7 to the 4 square. So P2 is true. Okay, P2 is true. Now, what can we do next? Should we plug in n equal to 3? I think I gotta stop from here. Okay, I'm going to stop from here. So I gotta finish this base step when n equal to 1 and 2. Okay, so let's go to inductive step. what can we do with inductive step? So we have to assume that P of k is true for any positive integer k such that k less than m. And what is m? And m is greater than or equal to 3. Okay, so let m be greater than 3. So m can be 3, 4, 5, 6, 7, and so on. And the base step, we have the case where n is 1 and 2. Okay, so now we're gonna have p of k. So we're gonna have p of 3, p of 4, p of 5, p of 6, and all the way and so on, because k is less than m and m is greater than or equal to 3. And the next thing that I have to do is to try to show that p of m is true. Okay, got it? So now, what can we do from here? Since k is less than m, right? Start from here. Since k is less than m and p of k is true. So when k less than m, k can be m minus 1 or m minus 2, right? So we're gonna have m minus 2 and p of m minus 1 are both true. Okay, once we have these two statements, what do we have? So we're gonna have a m minus 1 less than 7 to the 4 raised to the m minus 1, and a sub m minus 2 less than 7 over 4 raised to the m minus 2. All right, and we are talking about a Lucus sequence. What do we have? Okay, so we're gonna have that since the Lucus sequence is obtained by the sum of the two previous terms for any positive integer n such that n greater than or equal to 3. What do we have? So we're gonna have am, which is the sum of the two previous term, am minus 1 plus am minus 2. And a minus 1 is less than this term, so we're gonna have less than 7 over 4 raised to the m minus 1 plus 7 over 4 raised to the m minus 2. And then what can we do? So we're gonna have 7 to the 4, okay, times 7 over 4 raised to the m minus 2 plus 7 over 4 raised to the m minus 2. And then factorize 7 over 4 raised to the m minus 2. So we're gonna have 7 over 4 plus 1 times 7 over 4 raised to the m minus 2. And this sum is going to be 11 over 4 times 7 over 4 raised to the m minus 2. Okay, now what can we do next? I want to multiply this fraction by 4 on the numerator and the denominator. So we're gonna have 44 over 16, which is equal to 11 over 4. But what about this one? This is 44 over 16, which is less than 49 over 16 times 7 over 4 minus raised to the m minus 2. And what about this one? 49 over 16. 49 over 16 is 7 over 4 square times 7 over 4 raised to the m minus 2, which is 7 over 4 raised to the power of m. So we have a sub m less than 7 over 4 raised to the m already. Okay? Therefore, P of m is true. Okay? P of m is true right now. Okay? So we have proved the inductive step. Therefore, we proved this inequality already, which is P of n is true for every positive integer m. Okay, that is an, which is the Lucus sequence, less than 7 over 4 raised to the power of n for every positive integer n. All right, and that's what we have right here. Okay, so next time I'm going to prove this example. Okay, and that's it for today, guys.